Hello friends, in this session we will see some problems based on time domain analysis, stability as well as root locus. Let us begin. Yes dear, it is a GATE 2017 question. When a unit ramp input is applied to the unity feedback system having a closed loop transfer function is given, very important. Then the steady state error will be, now the first thing is we need to find the steady state error, right? Let us try to do so. Let us do some reverse engineering. See, we know that ESS, steady state error, is equal to 1 upon kV for ramp input. Is that correct? Yes sir. Now we see, now how to find kV? kV is what, sir? kV is limit as s tends to 0 into loop gain, correct? Or we can say open loop transfer function, that is G. Now here is the thing. See, they have not given us the loop gain, rather they have given us the closed loop transfer function, that is C of s upon R of s, which is the overall transfer function. That means we are supposed to find the loop gain now. So yes, see, for example, the T of s that is given, right, it is equal to what? It is equal to Ks plus B upon s squared plus As plus B. We have seen that in case of a unity feedback system, our overall transfer function in terms of G is nothing but G upon 1 plus G into H, correct? 1 plus G into H, wherein we know that H is equal to 1, so it is unity feedback, because it is unity feedback, right? That is the reason we have H to be equal to 1. Now what can we have here? We can have G upon 1 plus G over here, which is equal to Ks plus B upon S squared plus As plus B. Is that right? Yes. Now what will I do now? I will simply do the cross multiplication, take G on one side and try to find the solution. If I do cross multiplication, I will get, is that right? Yes. If I take G on one side and then put everything there, I get G to be equal to Ks plus B upon S squared plus A minus K into S, correct? Yes. This is your open loop transfer function G. Now let us find KV and then ESS. Very simple, right? Now how to find KV? KV is nothing but what? Limit as s tends to 0. What is that? S into G of S. Is that correct? Now this is equal to what? Limit as s tends to 0. What does that happen? By the way, here also this is just KV multiplied by S, because it is KV, right? If it was KP, then it would have been what? Limit as s tends to 0, loop gain, or we can say G. If it is Ka, then it becomes limit as s tends to 0, S squared into G, correct? Right. So if it is KV, definitely here also we are having S, right? Now, so what does that become? S into this Ks plus B, the whole G which is there, this one. Let me just copy that. Is that right? Now what will happen? Let me just take S common over here. What does that happen? Is that correct? Then this SS will get cancelled. Now if I place S to be equal to 0, I get, if I make this S as 0, this whole term will become 0, this whole term will vanish. The next is this 0. So what do you get now? You just only have B upon A minus K, right? KV is equal to B upon A minus K. But what is ESS? ESS is nothing but 1 by KV, which means inverse of this, inverse of KB, which means it becomes A minus K upon B. So this is the answer, A minus K upon B. If you check out, it has to be option D. So your option D is the right answer. Now let us see one more question. Yes dear, it is a GATE 1996 problem. Let us see. See, for a system shown in the figure, damping ratio is zeta of 0.7 and an undamped natural frequency, that is omega n, is given to be 4 radians per second. Now the values of k and a are. That is what they are asking. Let us try to see them. What is that values? So first of all, I've got this particular system, right? Let me find the closed loop transfer function of the same. What does that become? Closed loop transfer function of the same is nothing but g upon, because if you see this is the negative feedback, so it becomes g upon 1 plus gh, right, which is equal to what now? K upon s into s plus 2 upon 1 plus k upon s into s plus 2 into h. What is h? This is h, so it becomes 1 plus as, correct? If you solve this, you get that closed loop transfer function t of s to be equal to k upon s into s plus 2 plus k into 1 plus as. Okay, now if you check out, let me try to show it in terms of a standard second order system, right? So what do? I will send this s inside, this k inside, and then try to see what happens. I'll get s squared plus 2 plus k into a into s plus k. This is what we get, t of s, correct? Now I will tell you one thing. See, is this same as our standard second order system form? Let us see. What is our standard second order system? It is omega n squared upon s squared plus 2 zeta omega n s plus omega n. Is that right? Plus omega n squared. S squared plus 2 zeta omega n s plus omega n squared, correct? Now if you check out, this omega n squared and this k are equal, so I can say that it is equal to what now? So omega n squared is equal to k, correct? Therefore we can say that what? Omega n is equal to under root of k, square root on both sides, right? So I get omega n equal to under root of k. Is that right? Yes. Now what is omega n now? What is that? Omega n, you see, omega n is given to be 4 radians per second. Is that right? So if I just put it here, I will get 4, which is equal to under root of k. Now if I want k, then k is nothing but what? K is nothing but what? Yes, squaring on both sides, you will get root of k square is nothing but equal to k, and this 4 squared, which is nothing but equal to 16. So what have you got? You have got k to be equal to 16. So k to be equal to 16, it is option C, right? Solved. Very simple problem, right? Now let us see one more problem. Yes, it is GATE 2005 question. What does that say? When subjected to a unit step input, which means this is R of s and input is here, let us say u of t, which is what they are saying, right? U of t is the input, or the step input is given. Now the closed loop control system in the figure will have a steady state error of what? Steady state error of what? Now if you check out, the first thing we have to do is we have to find the closed loop transfer function. From that we can find loop gain, and then we can apply the things, correct? But now in order to find the closed loop transfer function, if you check out, you have got the summing point here, you have got one more summing point here, so things may become quite difficult for you, right? So what am I supposed to do now? What will I do is, see, I will use our signal traversal method. If you check out, at this point I have got YFS, the same YFS we are giving here, so this becomes YFS. Is that correct? Yes. Now this is R of s and this YFS. Definitely they are both good. This is plus and this is minus, so definitely here what signal I have? I will get R of s minus YFS, correct? Now what will happen now? This signal will get multiplied with this block, so here what will I get? I will get R of s minus YFS into 3 by s, correct? Multiplied by 3 by s. Is that correct? Now if you check out, the same R of s is coming here like this from here. This is the same R of s. Now what happens then next? Yes, this signal minus this R of s will be present here. So what is present here? Let me just show that here. So it becomes 3 by s into R of s minus Y of s minus R of s minus R of s. Is that correct? This is what is the signal here. Now what happens at the end? At the end here, what do you get here? Here at the end you get the same Y of s. Is that correct? So I can say that what is your Y of s here? So Y of s which is there, That will be nothing but equal to what? This signal multiplied by this block. This signal which is there here multiplied by this block, right? So it becomes 3 by s into r of s minus y of s minus r of s into 2 upon s plus 2. Is that correct? Yes. Now, if I try to simplify this, what will happen? If I try to simplify this, what will happen? If I just multiply these terms and everything, what do I get then? I will get, right? Y of s is equal to 6 upon s into s plus 2 into r of s minus y of s minus 2 times s plus 2 into r of s. Now next, what can I do now? What can I do now? Yes, I can take y of s on one side and I can take r of s on one side. So if I do that, what do I get? I get y of s into 1 plus 6 upon s into s plus 2. If you solve this, you will get this very easily. 6 upon s into s plus 2 minus 2 upon s plus 2, correct? Multiplied by r of s. Is that right? Yes. Now, if you think of what is a transfer function? Transfer function is what? Y of s upon r of s. So definitely, what is y of s? Y of s upon r of s. You get the transfer function to be equal to, if you solve this and if you simplify, you get 6 minus 2s upon s squared plus 2s plus 6. Is that right? Which is nothing but our transfer function t of s. This is what? Overall transfer function or the closed loop transfer function. Is that correct? But now, what have they asked you? They have asked you to find the steady state error, right? For steady state error, that too for unit step input, which means you definitely want ESS for unit step input. It is what? It is 1 upon 1 plus Kp. Is that right? Yes. Now, what is Kp here? Kp is nothing but limit as s tends to 0 into loop gain. Is that correct? Yes. So now if you check out what you want, you don't want closed loop transfer function, you want the loop gain or rather the open loop transfer function. So in order to find that open loop transfer function, we know how do we equate that. Our T of s is equal to what? Given to be 6 minus 2s upon s squared plus 2s plus 6, right? This one. Now that has to be equated to what? G upon 1 plus g, correct? Now what happens here? From this, if you just see, just cross multiply, what do you get then? You get 6 minus 2s plus g into 6 minus 2s, which is equal to s squared plus 2s plus 6 into g. Is that correct? Yes. Therefore, now let me take this g on one side. What do I get then? 6 minus 2s equal to s squared plus 4s into g. Correct? Now, what is g now? G is nothing but equal to 6 minus 2s divided by this term. So 6 minus 2s upon s squared plus 4s. This becomes my open loop transfer function g. Now, let us find Kp. Let us find Kp and ESS. What is Kp now? Kp is equal to what? Limit as s tends to 0 into loop gain or the open loop transfer function. What is the transfer function? The transfer function is here, right? Which is what? 6 minus 2s upon s squared plus 4s. What happens now? The moment I put s equal to 0, this becomes 0, this becomes 0. So anything finite and this becomes 0. So 6 upon 0 is nothing but infinity. Now you please tell me, if Kp is infinity, what is ESS then? ESS is nothing but 1 upon 1 plus Kp. So it is equal to 1 upon 1 plus infinity. 1 upon infinity is what? 0. So I can say that ESS is equal to 0, which is option C. So your steady state error for this is equal to 0. Now let us see some more problems. Yes dear, if you check out, it is GATE 2009 question. What does the question ask? It asks the unit step response of a unity feedback system with open loop transfer function. This is the open loop transfer function given, is shown in the figure. This is the, what do you say, step response, unit step response, right? And this is our transfer function, open loop transfer function, right? Now they are asking us to find the value of k. Let us try to observe something. Let us see. If you check out what has happened, see, they are asking unit step response. Unit step response, it means that it is the response or the output of the system when the input is unit step, correct? Yes. Now let me tell you one more thing. See, what happens is, generally, if your system is stable, like for example here, if you see, you can, at least from this open loop thing, you can say that System is stable, right? Yes. Now, if your system is stable, then what do you get? You get always the output to be equal to input. I mean to say, if your input is, let us say, u of t, then your output will also be u of t. That is what is expected, which means your amplitude has to be 1. So, what happens now here? But at steady state, is it u of t? No, because if it was u of t, or if it was 1, then its amplitude should have been 1 like this. But it is not 1. It is not 1. Rather, at steady state, you have got it to be equal to 0.75, which means there is definitely this steady state error over here. And that error is nothing but equal to 1 minus 0.75, which is the value now. So it becomes 0.25 becomes your steady state error. Now we will try to do something, try to see what can be done with this one. Okay. So what is ESS for a step input? It is nothing but 1 upon 1 plus Kp, right? Now ESS, we have seen from this particular graph, we have seen that it is equal to 0.25, which is equal to 1 upon 1 plus Kp. What is your Kp now? 0.15 means it is 1 by 4, which is equal to 1 upon 1 plus Kp. If you take inverse, you get 4 equal to 1 plus Kp. Kp equal to 4 minus 1. Therefore, you get Kp to be equal to 3. Is that correct? But do you want Kp? No. We want K, right? So what will I do now? Let us use the formula for Kp. What is that Kp formula? Kp is nothing but what? Limit as s tends to 0 g. Is that correct? Gh. So what does that mean now? Yes, limit as s tends to 0. What do we have here? Here we nothing but we have loop gain, or we also say that to be equal to open loop transfer function, and open loop transfer function is already available here. So it is what? K upon s plus 1 into s plus 2. So let me replace that here. So K upon s plus 1 into s plus 2. Correct? Yes. Now see dear, what is happening? Beautiful thing, beautiful thing. What has happened now? Do you know Kp value? Yes, we know that it is equal to 3. So let me put it here. Now what happens is, as soon as I put s equal to 0, this becomes 0, this becomes 0. So what do I get then? I get K upon 1 into 2, and this is 3. So what do you get? You get K to be equal to, this is 1 into 2, which is nothing but 2. So you get K, which is equal to 3 into 2. If I send this 2 here, I get 3 into 2. Therefore I get K to be equal to 6, which means answer is option D, which is 6. Correct? Very easy problem, but you will have to be a bit observant on it. Okay. Now let us see some more problems. Yes dear, it is GATE 2013 question. What does it ask you? The open loop transfer function of a DC motor is given as 10 upon 1 plus 10s. Okay. When it is connected in feedback as shown below, the approximate value of Ka that will reduce, approximate value of Ka that will reduce the time constant by, what time constant? By of a closed loop system by 100 times as compared to the open loop system is what? So first of all, we will try to find the time constant for the open loop system, and then we will check for the closed loop system. Okay, we will see that. Let us see what can we do. So what is open loop system now? It is nothing but this Ka multiplied by this 10 upon 1 plus 10s. So what do you have? You have this open loop transfer function to be equal to Ka into 10 upon 1 plus 10s. Is that correct? Let us see time constant for the same. What is that? If you check out, is it in 1 plus st form? We know that 1 plus s tau form is there, right? In which this tau is nothing but the time constant, right? If you compare, is it same like 1 plus s tau with s? What you have here? Here you have tau, hence we say that it is time constant. With s, here you have 10, so I can call 10 to be time constant. So I know that what is time constant of for the open loop system, open loop transfer function? It is nothing but 10, correct? Yes, that is what we have seen. Now what is next? The closed loop time constant, the transfer function said here, for the same open loop system, for closed loop transfer function means this whole, for the closed loop transfer function, if I think of the time constant they are saying, should be Time constant they are saying should be what? Reduced, very important. Reduced by 100%. What do you mean by reduced by 100 times? 100 times. It means that whatever is that original. Originally you have got 10, right? So it has to be 10. Now it has to be reduced by 100 times, which means it has to be divided by 100. So what do you get? You get it to be equal to 0.1. What does that mean? It means that your time constant should be equal to 0.1 for the closed loop transfer function. Now, best way. Let us try to find the closed loop transfer function now. Let us see how it is. So, how do you do that? Yes, this is g and this is h. So it becomes g upon 1 plus g upon 1 plus g, which is equal to, if you solve it, you get 10 times ka upon 1 plus 10 into s plus 10 into ka. Correct? Just replace it here, you can get this value, right? Now, what is that equal to? That is equal to 10 times k. What if I take, because if you see, this 1 plus 10k is a constant, right? So I will try to take 1 plus 10k outside. So I get 1 plus 10k outside. What do I get then? I will get it to be equal to 1 plus 10 upon 1 plus k. So it becomes 10 upon 1 plus ka into s. Is that correct? Now, definitely our 1 plus s top form, right? If you consider, you have got this s, you have got this s. Whatever is there with s, that is your time constant. So with s, I've got this one, which is the time constant. So I can say that 10 upon 1 plus k is the time constant for what? Closed loop transfer function. But now we have seen that the time constant has to be how much? 0.1, right? So if I place it to be here, 0.1 into 10 upon 1 plus ka, what do I get then? I get the value of ka to be equal to 9.99 something, which is approximately equal to 10. So I can say that ka is approximately 10. Why? Because see, they have also asked you the approximate value only, because they know that it will come approximately only. So answer is 10 and it is option C. Is that right? Yes. Now let us see one more problem. Yes, dear, it is GATE 1995 question. What is it asking? It is asking that closed loop stability implies that 1 plus g of s h of s has only dash in the left half of s plane. What will happen now? 99% of the people will say that the answer is poles. But let me tell you, the answer is wrong. Why? Because they are not asking you about transfer function. Because if they would have asked you that, yes, for transfer function say, then yes, definitely answer is poles. But they are asking you for 1 plus g of s h of s. What is 1 plus g of s h of s? We know that it is nothing but the characteristic equation, right? Now, and we say that we equate this equation to be equal to 0, and then we say whatever roots we get should lie on the left half of s plane. Is that right? In case of stability, which means the answer is not poles, rather it is roots. Very important. Answer is roots and not poles. Now, let us see one more problem. Yes, dear, it is GATE 1998 question. What is that asking? Let us see. None of the poles of a linear control system lie in the right half of S plane. For a bounded input, the output of the system will be. What will it be? Again, 99% of the people will say that the output will also be bounded. Why? Because, for example, this is S plane, right? Now, take none of the poles lie in the right half of S plane. Means on the right half of S plane, there are no poles. Correct? Which means student feel that no, then it means they are on this side, left half of S plane, which means system is stable, which means for a bounded input, definitely output has to be bounded, right? But they have nowhere said that the poles are on the left half of S plane. They have said that poles are not on the right half, right? Which means poles can either be on the left half or the poles can also be on the imaginary axis. Getting my point? Which means output is always bounded is wrong, always tends to 0 is wrong. The answer is that the output could be unbounded. Why? Now, students again say that, sir, on the left we have stable system, on the imaginary axis we have marginally stable system. Yes, I agree. So, student may say that, sir, but here if you see in our imaginary axis, if you check out, what will happen if my poles are there on the imaginary axis? Then what happens here? What happens? Again, the system is marginally stable, but the output which is there, that is also bounded, right? I agree with you. But what if there are repeated poles at origin? Repeated poles at origin. If you know, whenever we have repeated poles at origin, our system becomes unstable. That is the reason it could be unbounded. The answer is option B, that it could be unbounded. That is option B. Correct? Now, let us see one more. Yes, dear, it is GATE 2007 question. Okay. System shown in the figure is stable, unstable, conditionally stable, or stable for input U1 or stable for input U2. That is what we have to check. Now, if you see, you have got the inputs, yes, U1 and U2 are the inputs, but they have not at all given you the outputs. So, we will assume some outputs. Let us say, here the output is, let us say, C1, and here let us say the output is C2. How does that matter? I am assuming it, no? No problem. Okay. Now, what will I do? I will try to find the four combinations. What will be those four combinations? Means I will try to find C1 upon U1, C1 upon U2, C2 upon U1, and C2 upon U2. Is that correct? Let us try to do that. Now, for example, if I keep means CCC, when I'm applying this, we have seen that since transfer functions are not applicable for MIMO systems or for MISO systems, hence we use superposition, right? This is done by using superposition. In superposition, we do what? We activate one source at a time, or we activate one input at a time, and we deactivate all the others, right? Which means what will happen is, for example, if I am talking about only U1, then I will deactivate this U2, correct? It's gone, let us say, from the picture. Now, what happens? For example, U1 is activated, U1 is active, and I'm supposed to find, let us say, C1 by U1. What do I do then? I see that C1 by U1 is here. So, what do I check out now? I will have to deactivate U2. Done. Now, what happens is, I will consider this C1 to be the output, correct? Yes, it is considered to be the output. Now, what happens is, my input goes here through this block, output is taken, and then again from here, what is happening is I am going to have a negative feedback over here. Is that correct? Is that correct or not? Yes. Here you have negative feedback. This is positive. Okay. Yes. What do you have now? You have seen that you will be having this negative feedback over here, correct? Which means the transfer function will look like this one. This block will be in series. This is output C1. This is our output C1, and this will come here like this, and this 1 upon S minus 1, which is feedback now. This goes here this way, and this is our input U1, and this is C1. Now, please find C1 upon U1. It is what? It is a feedback system with negative feedback, right? Which means, how do you find that? C1 by U1 will be equal to what? It will be equal to G upon 1 plus GH, correct? Which is equal to what? What is G? S minus 1 upon S plus 2 divided by 1 plus S minus 1 upon S plus 2 into H. What is H? 1 upon S minus 1. So S minus 1 will get cancelled. This S plus 2 will get here S plus 2 plus 1, and this S plus 2 will get again cancelled. So at the end, what do you get here? You get S minus 1 upon S plus 2 plus 1, which is nothing but C1 by U1 is equal to S minus 1 upon S plus 3, right? What does this mean? Is it a stable system? Yes, definitely. Why? Because the pole is on the left half of S plane. Pole is S is equal to minus 3, which means it lies on the left half of S plane. So this is stable. Correct? Yes. Now, let us try to find C2 upon U1. Let us try to find C2 upon U1. What do I get then? Let us see. Means U1 is active. See here. When I say that, I am supposed to find, let us say, C2 by U1. This means that U2 is deactivated and only U1 is active, right? Again, same old story. But now what will happen this time? The output will be taken through this at C. So now your C is the output, this is the input. So your flow will go like this. This block will come, this will come, this will come, this block will come, and here at the output is C2. Is that correct? And then what you have is you will have a negative feedback over here, which is negative unity feedback over here. This is negative unity feedback over here, correct? See dear, again starts here. You will find this block first, then you will find the second block, you will get the output at C2, and then from C2 again you will get back to this U1, which means your block diagram will look something like this. Negative feedback, definitely. This is U1 and this is C2, correct? How to find C2 by U1 now? Yes, definitely. G upon 1 plus GH. What is H? H is equal to 1 because it is unity feedback, right? Now, negative feedback, that is the reason we have taken here plus, right? Yes. Now, G, what is G now? G is nothing but S minus 1 upon S plus 2. Upon again 1 plus S minus 1 upon S plus 2. After solving this, you get C2 by U1 to be equal to 1 upon S plus 3. From this, what do you understand? You understand that the pole is on the left half of S plane, which means it is a stable system. This means that, what does this mean? See, here we have taken input to be U1. Even previously we have taken input at the U1. It means that at least for input U1, for time being I am saying, for input U1, system is stable. Is that right? Yes. Now, let us take one combination based on U2 and try to see. Let me think of C2 upon U2. Let us see what happens to find C2 by U2, which means what? U2 is active, which means U1 is short circuited now. U1 is deactivated, means now what will happen? U1 is deactivated, whereas now U2 is active. If my U2 is active now, then what will happen? Input goes here and I am expected to take output here at C2, which means what is happening now? Input goes here, right, through this block, then I get the output C2, and then again I come back to pavilion, S minus 1 to S plus 2, and then again this one. But if you observe now what has happened, this block is in forward path, this block is in feedback path, because this is the output. You have taken this, tap this output, right? But what has happened now? Here you have got the positive feedback, here you have got positive feedback. So let us check out how the transfer function will look. Block diagram looks like this. Plus plus because it is positive feedback, and this is S minus 1 upon S plus 2, correct? This is the U2, right? Now, since it is positive feedback, what do you use? C2 by U2 will be equal to what? G upon 1 minus GH. Is that right? Which means what is G? 1 upon S minus 1. This is feed forward path upon 1 minus GH. 1 upon S minus 1 into S minus 1 upon S plus 2. S minus 1 will get cancelled. At the end, what you get is S plus 2 upon S squared minus 1. S squared minus 1 indicates that there are repeated poles on the right half at 1, which means system is unstable. So I can say now that for input U1 it is stable, but for input U2 system is going to be unstable. So answer is option D, stable for input U1 but stable for input U2. Is that right? Now let us see one more problem. Yes dear, it is GATE 2009 question. Okay, let us see. The first row of the Routh's tabulation of a third order equation is given. This is the given. Okay, this means there are two roots at s equal to plus minus j and one root in the right half of S plane. Two roots at s equal to plus minus j2 and one root in the left half of S plane. Two roots at s equal to plus minus j2 and one root in the right half of S plane. Two roots at s equal to plus minus j and one root in the left half of S plane. What will we do? Let us first try to complete the Routh's table. Okay, let us see what happens. 2, 2, 4, 4. This is what is given, right? Now, what is s power 1 row? S power 1 row will be equal to what? Definitely. 4 into 2, this into this, minus this into this upon 4, into again 4 into 2 upon 4, which is nothing but equal to 0. Which means what we get here is row of zeros. Is that right? Row of zeros. What do we do then? We take the immediate next equation or the immediate previous equation, which is this, and we call this equation to be auxiliary equation. So what is auxiliary equation here? A of s is equal to what? 4s squared plus 4 equal to 0. So from this what you get, s to be equal to plus minus j. What does that mean? It means that definitely there are poles at plus minus j, right? Yes, there are poles, which means plus minus j is there. So definitely this is not the answer, this is not the answer. Now let us check between a and b, which is the answer. Now if you think of, let us try to complete this s1 row. What does that mean? This is a of s. Now what we do for that, we take the derivative of the auxiliary equation, which is equal to d by ds of 4s squared plus 4. What is that equal to? 4 into 2 is 8, 8s plus 0. Is that right? Derivative of 4 is 0. Now this becomes 8s. 8s indicates that here the number can be 8 now, and this s power 0 row is nothing but 4. Correct? Now what happens here? If you see in the first row, see here you have positive, here you have positive, here you have positive, here you have positive, which means there are no sign changes. No sign changes. Which means what? No roots on right half of S plane. Is that correct? Which means all the roots are on left half. So this is the answer. Which means answer is option D. Two roots at S equal to plus minus J and one root in the left half of S plane. So answer is option D. Correct? Now let us see one more. Yes, dear. It was asked in GATE 1997. Okay. What does that mean? Let us see. The system represented by the transfer function. See, now this is transfer function. Transfer function in the sense, if they give only one transfer function, it means it is definitely closed loop transfer function. Whenever they say open loop transfer function, it is open loop transfer function. Whenever they say only transfer function, which means it is a closed loop transfer function. Remember this in mind. Okay. Now, next, what is the thing? Denominator of this one gives you the characteristic equation. Is that right? Now, what are we supposed to find now? We are supposed to find there are dash number of poles in the right half of S plane, which means let us try to find Routh's array. For that, let me write the characteristic equation. It is equal to what? It is equal to s power 4 plus 6s cube minus 39s squared plus 19s plus 84, which is equal to 0. Is that correct? Yes, this is what is written. Now, we will try to do the Routh's array. Let us see what happens. S power 4, S power 3, S power 2, S power 1, S power 0. That's it. Now, what do we do then? We don't have anything here, which means here I have 1. Now, what do we do now? Yes, we take alternate numbers, right? So, we will take 1, we will take minus 39, then we will take 84. So, we will have 1 minus 39 and we will have 84, correct? Now, S cube is what? You will have 6 and 19, correct? So, you will have 6 and 19 here. Okay, no problem. Now, let us apply this. What do we get? If you apply here, what do you get? You get this into this minus this into this upon this, right? Which means it is what? 6 into minus 39, correct? 6 into minus 39 minus 1 into 19 divided by 6. What is this equal to? This is nothing but equal to minus 42.166. Very important. Minus 42.166 is what we have got. Now, let us see what comes here. So, 6 into 84 minus 1 into 19 upon 6. Definitely this 84 will get copied here, correct? Now, let us find s power 1 row. How do you get that? Again, applying the same logic. This multiplied by this minus this multiplied by this upon this. What do you get then? If you do that, you will get that to be equal to, let us see, minus 42.166 multiplied by 19 minus 84 into 6 divided by what? Divided by 6 divided by minus 42.166, and it is equal to what? It is equal to 30.953. Is that correct? This is the first row. Now, what is this last one? S power 0. S power 0 is nothing but equal to 84. Correct? The same 84 will get copied. Okay. Now, if you check out number of sign changes, what are they? See, positive. Second one is also positive. Third one became negative. So definitely you have got one sign change here. Then what happened? Immediately fourth one became from negative, it became positive, which means definitely here I've got second sign change. And the last one is also positive, which means there is no sign change here. So in all, there are how many sign changes? There are two sign changes. Is that correct? Two sign changes. What does that mean? Two sign changes in the sense there are what? Two poles on the right half of S plane. Correct? Which means here it has two poles. Answer is 2 in the right half of S plane. Right? Thank you.